Welcome everyone. I would like to begin by thanking everyone for taking the time to attend this session. As you probably know, we recently launched our CDP public cloud services during the Strata conference. In this webinar, we introduce and demonstrate CDP Data Center, a comprehensive data management and analytics platform for on-premises IT environments. Data Center combines the best of both Cloudera and Hortonworks data platforms and provides new capabilities for our combined customer base. I will begin today's session with a brief discussion of the on-premises DBMS market. Next, Matt Schumpert, Director of Product Management, will provide an overview of CDP Data Center offering and demonstrate a key capability, Virtual Private Cluster, which alleviates resource contention. Then, Wim Stoop, Product Marketing Manager, will discuss how shared data experience brings consistent security and governance to data center. Lastly, Srikanth Venkat, Senior Director of Product Management, will demonstrate the power of Ranger, including fine-grained security. In a recent research paper, The Future of the DBMS Market is Cloud, Gartner states that of total worldwide DBMS revenue, 75% continues to be from on-premises implementations, about $34.5 billion. This observation reflects that on-premises remains crucial for mission-critical applications. In a recently published survey-based research report, Voice of the Enterprise Data and Analytics, 451 Research asked respondents to identify IT environments they use for data platforms today, as well as the IT environments they plan to use 2 years from now. In this chart displaying the survey results, I want to highlight that today, 49% of respondents are using on-premises and 36% are using on-premises private cloud for data platforms as indicated in blue. These two IT environments are utilized to a greater extent than other IT environments. As indicated in orange, enterprises plan to continue the present level of utilization of on-premises private cloud IT environment over the next 2 years. During Matt's presentation, he will discuss how our data center offering provides a foundation for private cloud and containerized applications. Percentage of planned use declines for pure on-premises due to increase in PaaS, IaaS, and SaaS utilization. Nevertheless, on-premises will remain a viable location for future deployment of data platforms. This graphic is a conceptual view of Cloudera data platform that illustrates different data platform locations supported by CDP, for example, data center, private cloud, hybrid, and multiple public clouds, all with unified security and governance, analytics spanning edge to AI, and a single pane of glass for management. Now I will hand off to Matt, who will cover data center, which you've been waiting for. Thank you.
First, let's start with what is CDP Data Center. CDP Data Center is really combining the best of both worlds of CDH Enterprise Data Hub and HTTP Enterprise Plus. It's really a fusion of the latest and greatest open source data management technologies combined together, upgraded to the latest available versions available in the open source community, integrated to work together, and optimized for deployment within the data center. So what's the same about CDP Data Center? Well, you'd get the benefits you traditionally expect from both CDH or HTTP. The ability to store and process enormous volumes of data at a fraction of the cost of other solutions. The ability to bring to bear a wide range of workloads against those data sets with common data catalog, security, and governance that's enterprise grade. And the ability to get world-class support from the engineering teams that create and maintain these technologies, not just a vendor that packages them and brings them to the market. Now I want to talk a little bit about what's different with CDP Data Center. Well, I think there's 3 main categories of things that have changed. First, whether you're coming from CDH or HTTP, there's a lot of new feature functionality available to you in CDP Data Center. Second, we have a new unified distribution and a new delivery model that's going to give you more features and more stable releases available sooner. And third, CDP Data Center is a prerequisite or a stepping stone for consuming the next edition of CDP called CDP Private Cloud and its suite of containerized workload applications. All right, now I want to drill down a little bit into what's new in terms of feature functionality in CDP Data Center. If you're coming from the CDH world, there's a number of important capabilities around fine-grained access control, leveraging Apache Ranger. These are things like dynamic row filtering, column masking, attribute-based access control, as well as fine-grained security for Spark SQL users. Additionally, there's new SQL engines like Hive-3 available, which provide ACID support. So it's less work on development teams because you have transaction semantics available to you when you're working with tables in Hive. You also have more comprehensive coverage of the ANSI SQL 2016 standard. And finally, for ETL, you'll have better performance with Hive on Tez as compared with Hive on MapReduce. If you're coming from the HDP world, you'll have a new and improved cluster management experience or management plane called Cloudera Manager. It allows you to manage multiple clusters, automate the setup of wire encryption and other security aspects, have fine-grained administrative controls for different administrators of different clusters, and streamline maintenance workflows. You'll also have a new SQL engine called Apache Impala, which is a better fit for data mart use cases, ad hoc BI use cases with interactive query performance. You'll have a new SQL editor with Apache Hue, and you'll have a new data store for fast-changing data, frequently updated data called Apache Kudu. Whether you're coming from the HDP world or the CDH world, there's new capabilities for all of you. Some of these capabilities were introduced later on in the CDH development cycle, like virtual private clusters and HDFS erasure coding. Virtual private clusters is a very unique capability that allows you to separate compute and storage and create multiple different independent compute tenants to avoid issues with noisy neighbors while operating on shared data, again, with a common catalog, security, and governance under one management plane. Apache Atlas 2.0 is really the merge of the best feature functionality from Atlas as well as Cloudera Navigator in providing end-to-end governance and the foundation for attribute-based access control with things like tag-based policies, things that Srikanth is going to cover later on in this session. It also provides lineage around Spark workloads. And finally, a new capability in the storage world is Apache Ozone. This is available as a tech preview in the first release of CDP Data Center, which provides you a lot more scalability and an S3 style interface for interacting with very, very large file systems and sets of data. And I'm going to drill down into that in a later slide. Okay, the second major thing that's changed with CDP Data Center is that it is a new distribution model for Cloudera. So we've combined the best of both technology assets, as I mentioned previously, but now we have almost double the size of the engineering team working on this common code base, this common platform. So we're no longer developing competing technologies or overlapping feature sets. We can also crank out more bug fixes, more improvements, more new features, and adopt more quickly the new releases that are made available upstream in the open source community. So that basically just delivers you more functionality and more robustness faster as opposed to what we could do separately as two different companies. Secondly, we have a shared development model with our public cloud form factor, CDP Public. So every on-premise release has basically been battle tested for several months with real workloads run by real customers in the public cloud before it's cut into a release of CDP Data Center for consumption on premises. So it allows us to iterate more quickly and deliver more stable releases in the data center than we could previously. The third major thing that's new here is that CDP Data Center really sets up customers with a foundation that's ready for the next edition of CDP, CDP Private Cloud, which will be launched next year. So what happens is CDP Data Center is really the building block or the foundation of a CDP Private Cloud deployment. It contains all the stateful aspects of a deployment. The data, the metadata, the security, the governance, of course, hardware. Usually this is an existing cluster that customers are upgrading from either CDH 5 or 6 or HDP 2 or 3. So the first steps are really putting that foundation in place by performing that upgrade, getting onto the latest versions of the storage systems, of the security and governance components of the data catalog, doing that migration, for example, from Apache Sentry to Apache Ranger for security policies, and getting that foundation in place, which then makes it much easier for you to be able to consume this new family of containerized workload experiences, some of which we launched in the public cloud this summer, including Cloudera Data Warehouse and Cloudera Machine Learning, and others which we'll be launching next year, like a data engineering experience and a data flow experience as well. Upgrading to CDP Data Center now really puts you on the right path to be able to operate with the latest technologies that are going to be available next year with CDP Private Cloud. All right, let's dive a little bit deeper into what's actually in the box with the first release of CDP Data Center and what we're going to be offering with follow-on releases. So you can see here some of the component versions there. including the open source components, as well as a major new release of Cloudera Manager, Cloudera Manager 7. As I mentioned before, we're taking the latest available releases from the open source community, some of which were offered by Hortonworks, some of which were offered by Cloudera, to really offer our customers kind of the best suite of overall components, whether it's SQL engines or storage systems or file formats or tools that weren't available necessarily in one release or the other, one distribution or the other. There'll be other capabilities that we'll be offering in a follow-on release. So we plan to have regular minor updates to CDP Data Center, and these are things like Hive LLAP, which is currently available in the cloud in Cloudera Data Warehouse, as well as Apache Knox, Zeppelin, and Livy. All these capabilities, again, already available in CDP Public Cloud, will be brought to an on-premises release of CDP Data Center in the coming months. In addition to the core package itself, there's a number of add-ons coming, one of which is available right now, which is Workload XM for workload management and optimization, available to all customers on older platforms as well as the new platform. And then some of the data flow capabilities and stream processing capabilities leveraging Apache NiFi and Apache Kafka, as well as other value-added components that's brought to bear from the Hortonworks data flow product family. Now the Cloudera data flow product family will be available to users of CDP Data Center in the coming months. All right, now one component I want to dive into a little bit is a new component called Apache Ozone. Again, this is available in a tech preview in the first release of CDP Data Center. There's a couple of things we're going after here with Apache Ozone. One is extreme scale, so scaling up to billions of files or objects, handling small files efficiently. In fact, we actually have test clusters right now already running systems with over 1 billion objects in them. And this is not really possible with HDFS, which tops out around a few 100 million files. The second is flexibility to access through an S3 style interface using the ubiquity of the S3 protocol out there. And so customers will be able to access Ozone either through typical HDFS interfaces or the object store style S3 interface. And we'll do all this without sacrificing security. So support for Kerberos, first class support for Apache Ranger, fine-grained authorization, as well as support for encryption at rest. Again, without sacrificing other aspects you've come to expect from HDFS, like consistent high availability and so forth. And all of this will be managed through Cloudera Manager. Okay, let's zoom out a bit. CDP Data Center is just one addition within this family of new products called CDP, and it's part of our overall hybrid and multi-cloud architecture and product strategy. So there's been the launch of CDP Public Cloud this summer, including Cloudera Data Hub, as well as 2 of the containerized experiences available in the public cloud, starting with Amazon, eventually in Azure and Google Cloud as well. These containerized services are known as Cloudera Machine Learning, Cloudera Data Warehouse, and they provide the ability to run side by side on shared data thanks to Cloudera SDX. We're taking this same form factor next year and bringing it on-premise in CDP Private Cloud, as I've alluded to earlier. But the interesting bit here is that all of these various form factors, whether they're public cloud, private cloud, or bare metal style deployment, which CDP Data Center is, can be part of a worldwide deployment that is connected with data and metadata being replicated and the ability to see all of this in a bird's eye view from the CDP management console. The ability also to have a common data catalog across all these deployments worldwide in various data centers and clouds. The ability to synchronize data sets as needed, the ability to burst into the cloud when needed, when more capacity is needed for a workload that's based on-premise, and the ability to analyze and optimize workloads using Workload Manager, regardless of whether the workloads actually run. Again, in bare metal, in your container cloud, in your data center, or in the public cloud. Now I want to dive into a quick demo to show a couple of aspects of CDP Data Center. The first is some of the unique capabilities of Cloudera Manager in managing multiple clusters with push-button security and a variety of workloads. And the second is this notion of virtual private clusters, or the ability to separate compute and storage, have independent compute tenants that don't run into noisy neighbor issues, that can be scaled up and down and created and destroyed independently, but operating on shared data with a common data catalog, security, and governance. So now I'm going to demonstrate some of the multi-tenancy capabilities available in CDP Data Center that support self-service administration, tenant isolation, the separation of storage and compute clusters, as well as talk briefly about some of the newer capabilities in Cloudera Manager that might be new to existing HTTP or even CDH customers. So I'm going to jump into Cloudera Manager for this demonstration. The first thing you'll see here at the homepage in Cloudera Manager is that I actually have multiple different clusters under the management of a single instance of a Cloudera Manager. They all have different hosts, different services, running different use cases. And what you'll also see is that I have so-called compute clusters, as well as what we call a base cluster, which contains the storage, security, and governance services needed to provide end-to-end security and governance for all of the various workloads that the various application teams want to deploy. So in this base cluster, I've got HDFS, I've got Apache Ranger for fine-grained authorization, Apache Atlas for lineage and audit and creating a classification of data and tag-based policies, and all the other supporting services as well. And then in the other clusters, what I have is just my compute services. So things like Hive or Spark or Impala, and the necessary tools, for example, that are required to use those services, things like Q or Data Analytics Studio or Apache Zeppelin for running Spark workloads. And what we'll see is that all three of these clusters, independently of each other, are connected to this base cluster, this common base cluster, through what's called a data context. So the data context is really what keeps track of all the configuration details of the common storage, metadata, and security services running in the base cluster, and make sure that everything is in sync, so that if something changes with respect to the Hive Metastore, Ranger, Atlas, HDFS, all the various compute clusters that are connected into that data context will get the common configuration updates, and they'll know when they need to be restarted. They'll make sure that they're running compatible versions of Hive and Spark and Impala, and so on and so forth. And so what we can also see here is that we can make the administration of these individual, what we call virtual private clusters for the different application teams, completely isolated. So we can go to the administration and user area and see that we've created different administrators like admin 1 for Hive cluster or administrator 2 for the Impala cluster or the Spark cluster. And I can very easily manipulate these roles and say, for example, I'd like to define a new role that someone should be the cluster administrator or the operator on a particular cluster like the Spark cluster, and I can grant that to a certain user or maybe an LDAP or Active Directory group. What that means is if I go and log in here, for example, as administrator number 2, I should only have access to the cluster that actually belongs to me. In this case, it could be the Impala cluster, or if I'm administrator 1, I'll have access to which should be the Hive cluster here. And all I know is that I'm connected through this data context to the various storage and metadata and security and governance services you see here. So these services on the top here, those are really proxy to another cluster that's managed by a separate administrator, but it's all under the governance of one management plane with one single instance of Cloudera Manager. So you can very easily isolate the management and monitoring, configuration, maintenance, all the activities associated with each of these clusters to different administrators. But one really nice thing that you can do as well with Cloudera Manager is manage security. So while I have all these different clusters and they all have different security certificates and Kerberos principles and so on and so forth, what you'll see is it's very easy to manage all of that and configure all that here from this security dashboard as the global administrator. So I can see which clusters have been Kerberized, which ones have encryption at rest, encryption at transit. I can rotate my keys automatically for the encryption in transit. I can configure all of the wire encryption settings very, very easily. And when I create new clusters, all of this gets configured automatically. So from within the same Kerberos realm with the same KDC that's known to this Cloudera Manager, all of those settings will transparently get set up every time I create a new cluster. So immediately they're just Kerberized, they have wire encryption, and you can very easily set up encryption at rest as well. And you can use this single instance of Cloudera Manager to manage up to 3,000 nodes running various different compute frameworks like Hive and Spark and so forth. Okay, now let's take a look at what the experience would be like for self-service cluster creation. So let's say I wanted to go in and create a completely new cluster as administrator number 2. And if I go back in here, you'll recall that I had that Impala cluster created, but what I want to be able to do is create a new cluster, and I've been given the cluster creation rights by the global administrator. So the first thing I'll do is choose the type of cluster. This is going to be a compute cluster called my Spark cluster. connected to the data context we've already seen. And you see here what of the storage, metadata, and security services inherited through this data context, such that I don't have to create or manage those myself. I'm really just concerned about the compute frameworks. I'm going to choose some hosts, in this case, a simple demo. So I just have one machine here. I'm going to install the appropriate version of the Cloudera runtime, which is all of the binaries for the various components I want to deploy. Cloudera Manager is going to unpack and deploy those binaries. And then when that is done, I'll have the opportunity to test the network performance of this cluster in combination with the separate storage clusters. So we can test both the latency to the storage cluster and the cross-sectional bandwidth of all the nodes in the compute cluster against the storage cluster. And this is really important when you're dealing with this separation of compute and storage. Okay, so I'm going to skip this step for now and go forward. And Cloudera Manager is going to ask me what type of cluster to create. For example, one of the pre-built templates for data engineering, or an Impala Data Mart, or Spark with Uzi for scheduling, or maybe just a very simple cluster with exactly the services I can just pick and choose that I want. Let's say, Yarn and Zookeeper and Spark here, because I want to have an HA Yarn, which requires Zookeeper. I'll be able to position the various components on all the various hosts. And as I go forward, it's going to auto configure things like wire encryption for me, Kerberos, and so forth. So all of these settings here associated with wire encryption are automatically populated and configured in accordance with the certificate authority that's provided by Cloudera Manager, or that the customer themselves has provided separately, or is within their identity management system. So now it's going to go ahead and build this cluster and run all of these services for the first time and spin them up, and then I can go ahead and start using that cluster. Okay, now back as administrator of the global system, I want to take a look at a little bit more how the collaboration takes place between these various tenants. So I'm going to have a look at my base cluster here, and you recall I mentioned there's a common Apache Ranger for security and Apache Atlas for audit and lineage and classification of data. So I can just jump right into Apache Atlas here and see all of the objects that have been created in this environment. There's not much here in this test environment, but I can see, for example, that maybe somebody has already created a table, and actually using a Spark application, they've actually prepared some data and created a table called user ID. I can quite easily see the lineage of that table. So what's the folder of the raw data that populated the table, and who actually did that? Actually, it was created here, in this case, by Spark itself on that separate cluster. So this view of the audit and lineage, of course, and metadata spans all of the clusters that are within this particular environment. Now, I'm not going to show you fine-grained access control because Srikanth is going to cover that with Apache Ranger a little bit later, but I do want to show you the other cluster I have here, which is the Hive cluster, and just a little bit more about how it's connected to this separate storage cluster. So what you see here is what we have is Hive on Tez for running our ETL workloads. We have Yarn for providing the compute resources and orchestration of concurrent workloads and so forth. We have Apache Hue as a query editor. There's also Data Analytics Studio, which is another option for querying Hive. And then we have HDFS only for temporary data. And the important thing here is that everything is automatically configured to point to this shared HDFS, and as well as the shared Hive metastore running on the base cluster where all the catalog table definitions exist and so forth. So I can jump right into Hue as well, as a SQL analyst wanting to access data on this base cluster, and I can see that this table here has been created by the Spark user, and I can actually go ahead and query it and easily get my data back there, even though the HDFS that is backing this particular table is actually on a completely separate cluster. So from my point of view, this is just HDFS. I use a normal HDFS URL, but Cloudera Manager has taken care of stitching all these clusters together, and it knows that the default file system that should be used here is the file system running over on that other cluster, the base cluster, again, managed by different folks. So you have kind of three different players here. You have the person responsible for managing the storage and the core security and governance services. You have the data engineering users running the Spark jobs that populate the catalog and populate the data sets in HDFS, and then you have the SQL analysts that are actually querying that data, or the Hive users or Impala users, whatever the SQL engine of choice is, all collaborating around this single shared data lake, if you will, within your data center. All right, that's it for the demonstration. Now we'll pass it over to Wim.
Thanks, Matt. So, what are some of those key benefits and use cases of CDP Data Center? It empowers an organization to focus on delivering trusted, high-value analytics from the edge to AI-powered applications in a cost-effective manner. It lets you achieve new levels of security with advanced authentication and authorization capabilities, spanning attribute-based access control, dynamic masking, fine-grained access, and more. Virtual private clusters decouple compute from storage to improve isolation and boost multi-tenancy, letting you add new application use cases and teams with ease. With Data Center, businesses can expand to new experiences thanks to its solid foundation for containerized compute applications. And with that, you can drive tremendous benefit and value to grow, connect, and protect your business. And with growing business, we mean increasing revenue, improving customer satisfaction, and powering new business models through data-driven insight for example, marketing automation, personalized marketing, churn prevention, or customer retention. You connect operational technology, real-time and streaming IoT data, and contextualize it to achieve operational excellence for use cases around predictive maintenance, connected vehicles, smart cities, healthcare analytics, and industrial IoT. And finally, using data-driven insight to facilitate compliance, eliminate security threats, and ensure privacy for use cases that target regulatory compliance, risk modeling analytics, financial crime prevention, fraud detection, as well as cybersecurity. Let's look at how consistent data security, governance, and control fits in all of this. And that's delivered by CDP's Shared Data Experience, or SDX. That consistency delivers distinct business benefits. Operational costs and overheads go down for IT as there is but a single platform to maintain across any and all infrastructures and workloads. As a result, security risks are reduced. Vendor lock-in is eliminated as workloads can be deployed anywhere, allowing changing business needs to be met by dynamic deployments across infrastructures. And ultimately, safe, self-service access to data and analytics increases business agility and insight. And centralized governance makes regulatory compliance straightforward. SDX provides the key services to do just that. A comprehensive data catalog for all data, providing safe, self-service access to data to discover it, curate it, and share it. The automatic capture and storage of all schema and metadata definitions as they're used and created by the platform workloads. Granular, dynamic, role and attribute-based security policies, including data encryption across the stack at rest as well as in motion. And enterprise-grade auditing, lineage and governance capabilities applied across the platform with rich extensibility for partner integrations. But finally, replication. Delivering data as well as associated policies there where the enterprise needs to work. And like the rest of the platform, SDX is implemented using common open source components like the Hive Metastore, capturing and storing any and all structures, schemas, as well as metadata definitions as they are discovered and created by platform workloads. Apache Knox, or rather aspects of Knox, to deliver single sign-on across the platform. But let's dig a little bit more into two crucial components, those looking after security and governance. Apache Atlas delivers governance for both end users and data stewards. For end users, it enables self-service access to trusted data and analytics, lets users find and curate assets and collections from a shared catalog that puts all information in context. It builds trust through lineage, impact analytics, and a glossary gives context in a natural language. For data stewards, it provides a unified data management operation, creating and managing data authorization policies as well as auditing them. Sensitive data can quickly be discovered, identified, and managed, effectively addressing compliance requirements. Linked closely with Atlas is Apache Ranger, delivering enterprise-strength security with centralized, granular, consistent access control, including attribute-based access control, role-based access control, dynamic column masking, and row filtering, consistently applied across all of the data sources. And reaching back into Atlas, also have classification-based security. We can also do metadata authorization policies. Who can see which metadata? And what's more, Ranger also provides encryption through the Ranger KMS, and it uses that to encrypt HCFS. It has a rich key lifecycle and policy admin GUI. Key management is done through a customer-supplied database or with an external hardware security module. So with that, let's delve deeper into Ranger and the role it plays for the Cloudera data platform. So Shrikant, what can you show us?
Thank you, Fim, for that introduction. Um, what we are looking at here is the CDP Data Center Edition, the Cloudera Manager console on top, which will help you manage all of the services within the Data Center Edition seamlessly. And in particular, we'll focus on the security and governance relevant components here, which are Apache Ranger, and Apache Atlas. Apache Ranger is a central authorization console, and it provides auditing and fine-grained policies for controlling access to resources across the entire stack and other services that are managed within the CDP Data Center Edition. And Apache Atlas provides metadata and governance services that complement some of the fine-grained access control, auditing, and other capabilities that are relevant for having a robust, always-on compliance with very rich capabilities for security and governance that are provided via the CDP Data Center Edition. So we'll look at both of these in a little bit of detail as part of this demo. So I'm going to now navigate to Apache Ranger console, log into this UI. And when I log into this UI, you see here that the main console, we see a number of different services noted here with links to what are called policy repositories, where you write the relevant policies for controlling access to the specific resources or objects within those services. So for example, you can write very, very fine-grained policies on the basis of the service and the objects and the different capabilities that exist within that service. So you could write, for example, policies on a Hive database table or column, an HBase column family, or HDFS file or folder, a yarn queue, or a Kafka topic, or a Solr index. So depending on the type of service, we have different types of different levels of fine-grained authorization that are provided. We will primarily look at the SQL-based authorization here that will apply uniformly for Hive, Impala, and the Hive Metastore, which is part of this Hive policy repository that you see here. So Apache Ranger provides you an intuitive console where you can author these policies and manage them at a very fine-grained level and with the right appropriate authorization for who can do what within this ecosystem. Apache Ranger also has different roles for who can author these policies and who can access different parts of the application console that you see here. So let us first look at the data security angle, which is for Hive or Impala or Hive Metastore, how do you author policies that control access to different tables, databases, or columns, or even fine-grained level UDFs, etc. Let's take a simple example. Here's an access control policy for a particular table. We have a database called Worldwide Bank in this demo instance, and that has a table called US customers, where this particular bank is collecting all of its customer data from different CRM systems. And we want to write policies that control access to all of the columns, let's say, for this particular table. Apache Ranger is by default a secure model. What this means is that unless you allow explicit permissions for a set of users or groups or roles within your organization, by default, they will be denied access. So by default, it's secure, and you can allow permissions at a very, very fine-grained level to be able to control access to the data that exists within the different services within this ecosystem. So what this policy is showing here is that for this customers table, on all of the columns, the US employee and the data protection officer group is allowed only select permission on those columns, whereas the admin role within this organization is allowed all permissions. They can do, for example, select, update, create, drop, etc. And Apache Ranger also provides you the ability to delegate administration, meaning if you check this box here, these sets of users and groups can then further administer and provide access control policies for others within their scope for these resources. Apache Ranger also includes the ability to do both inclusion and exclusion of these policies, as well as negative permissioning through deny. So you could say that you do not want to provide access or deny access to certain folks. And in this case, what this deny condition block is showing is that except for the US employee DPO and the admin role, everybody else, which is public, is denied access to this particular type of this particular set of resources, which are the columns on that US customers table. Apache Ranger also provides dynamic row and column level security. So you can write dynamic masking policies that transform the data on access. Again, this is a very critical capability that relies on the attribute-based access control infrastructure that is part of Ranger. And this has the benefit that you don't have to maintain multiple copies of the data, which are transformed or anonymized suitably. On access, you can transform the data and show the right view or right transformed view of the data within these columns to a particular user or a group in context. And this means that you don't have to change your application code or have to maintain multiple copies of the same data, for example, masked and unmasked versions of the data within your environment. And it's very simple to author those policies. So let's look at a simple example here. Here's a policy where we might have social security numbers in a national ID column on that same customers table. So from the CRM system, we're also getting the social security numbers for those customers. And what we want to be able to do is whenever an analyst accesses this, the groups and users here can come from your LDAP or AD. We can sync these to your AD or LDAP infrastructure or your user repositories. And as in when you author these policies, different possible completions are shown. So it's very simple to author these policies with the assistance provided within the UI itself. So in this case, we can transform or mask the data in multiple ways on access. And what we are this policy here, what it's doing is taking the last 4 digits of the social security number and only showing that whenever anybody from this analyst group accesses this data. So this is one example of a policy. There's also other things you can do, other operations you can do. In this case, for passwords, you can hash those. There's also nullification available. You can just retain the original value if you want to layer the policies and policy conditions depending on different groups. And you can also apply custom transformations. For custom transformations, all you need is a UDF. And as long as the UDF returns the same type as the column to keep any data integrity constraints are defined on the column, you should be able to use those UDFs to be able to do the transformations. Here's an example of a custom masking function where we're taking the age and we are randomizing the age by adding a number between 0 and 20 to the age of the customer's age column in that table. Another type of attribute-based access control policy is applicable for the row level filters. Let's look at an example here. So the example here shows that for this worldwide customers table, which has the data for customers coming from a CRM system as an example, when the US employees access this table has rows for customers from all over the world. And you want to be able to show only the right slice of the data depending on who's accessing that table. So when a US employee accesses this table, only those customers who are residing in the US, as noted by the filter condition here, which is just plain SQL, where the country of that customer record is US, only those records will be shown and the others will be filtered out. When an EU employee or an administrator accesses this, then we go look up another table, which is EU countries table, which has the master data for what countries are currently in the EU, and also further apply a selection condition. As an example here, we've included a consent-based condition, let's say for GDPR or CCPA, which require you to maintain explicit consent for access to specific data and also for specific applications within your environment for that customer's data. Here's an example of how you can do that very easily using dynamic views. So what this row filtering or dynamic row level security gives you is the ability to filter the data and show the data in the right context for the right sets of users without having to maintain multiple views. So anytime access happens to this worldwide customers table, automatically behind the scenes, this filter is applied. So you don't have to, for example, maintain multiple views, one for US employees and one for EU employees. And furthermore, as and when you have Hive Acid turned on, for example, you will be able to deal with this on a transactional side and be able to do this near real time as and when the data changes. So for example, a particular customer has withdrawn consent, then that customer row will be filtered out based on this predicate, because we're looking this up in the consent master and checking that the individual customer has given consent for use of their data for analytics purposes. So in this way, we can provide dynamic row and column level security at scale and provide this in a very easy, usable form within CDP Data Center Edition. In terms of how this works, let's take a quick example. Here's a person from this organization who belongs to the analyst team. His name, we're calling him anecdotally Joe Analyst, and he's trying to run some analytics on using the platform on the data that exists within Hive on those customer tables where we had written the policies. So the first thing he's trying to do is do some demographic segmentation based on the customer data, and then he's looking at detailed records of the customers. So in this case, he's trying to run a query on the Worldwide Bank database, the US customers table, for which we looked at policies before, where we had a bunch of masking policies on the columns within that table. And when he tries to access this data, as you can see here, the street addresses got redacted, the passwords got hashed, the ages got randomized, the social security number, you can only see the last four, credit card numbers, you can see the first four, the medical record numbers have been nullified, etc. So you can see that all of those policies that we authored within Ranger have been applied. And in addition, we also have full non-repeatable audits of all of that access. So here's within the Ranger console, we also have the ability to show you all of the audit events as and when they happen. And this is done near real time. So you can see here all of the different accesses that happen to data based on this particular user. I'm going to look at the Hive events just to show you what happened when we ran, when the analyst ran these queries. You will see that the row filter on the table got applied. Then you'll also see that the various masking policies that we looked at, for example, the national ID policy, which said to show the last 4 digits of the social security number. We have an audit record here that shows you what exactly was the policy that allowed access, who was the user, in what context they accessed this, what was the date and time of access, what was the outcome, and we also see where was this run from, the client IP, the cluster that it's in, as well as any other metadata such as tags or classifications that you might have applied on that data. So in this way, Apache Ranger gives you the ability to write very fine-grained policies per the type of resource across the different services, gives you a non-repeatable source of audits where you can track what happened as access to those different events happened. So we include even rich information such as the actual query that the user ran while they were trying to access this. And we also show you all of this rich even metadata corresponding to each of those accesses and the outcomes, whether the user was allowed or denied based on the policies that are in effect. So in addition to the resource-based policies, we can also do classifications and on the individual resources, and that is done via our metadata and governance tooling called Apache Atlas. Apache Atlas is a highly performant metadata service which gathers metadata from different services across the platform and is aware of the changes happening to metadata across different services and the objects within them. So for example, we have built-in connectivity to Hive, Impala, Spark, and other services across the ecosystem. And as and when changes happen, there are agents that capture all the changes to the metadata and push that into the Atlas metadata service in a scalable fashion. Apache Atlas, because of all of the metadata connectivity it has across the ecosystem, gives you a central place to look at cataloging all of these assets and understanding the properties of these assets and how they relate to different operations you might have within your ecosystem. So it is at the very core a catalog. So the first thing you would do with a catalog is a search. So let's go here and look at, maybe I want to first look at all of the Hive tables that are in this particular instance. And if I do a search here, you can see that there are around 25 tables here. And then I can also filter the tables and apply various search criteria, such as who's the owner, when was it created, etc. So full faceted search is available. You can also do quick searches from here. So let's say I want to start looking at anything that starts with US underscore, the same table that we looked at earlier where we had masking policies. You can see here that we can very quickly get to that table, and a lot of very rich technical and business metadata is provided here. For example, what are the columns, when was it created, what database is it part of, etc. We also provide the full lineage chain. So in this case, you can see that this particular table was created from this AWS S3 location, and we have the US customers table being created through this Hive process, and it was inserted into this table. And then another derived view was created, a transactional table was created from this particular table, as is shown in the lineage diagram here. We also have the ability to represent relationships natively within Apache Atlas, so you can relate the different tables to its columns or databases or storage descriptors, etc. And you can also apply various classifications. So the classifications, think of the classifications as labels that you apply to different data. For example, you can apply the fact that certain columns have PII information through this PII tag. Adding these tags is very straightforward. You can select and find the columns that you want. So in our case, we found this table. Let's say we go to the US employees table, and then we can go to the columns on the table through the schema tab and add classifications. Let's say the salary is PII information. You can go and apply the tag called PII to the salary data for employees. And this classification gets applied. Once a classification gets applied to this column, the association of the column with the classification gets published into Apache Ranger, so you can write policies based on the tag itself. The benefit of doing this tagging in Apache Atlas is the ability to do cross-service global policies that pertain to the type or classification of a particular object independent of the service that's sitting in. So for example, if you have a Kafka topic through which PII information is flowing, then you can tag the Kafka topic as well as the HDFS location at which this file or folder at which the Kafka topic landed this data, and also the Hive table from which that particular HDFS location from which it was created. So we can use the lineage capabilities to automatically propagate such classifications and also write very fine-grained policies in Apache Ranger to affect them through what are called tag-based or classification-based policies, which gives you the attribute-based access control flavors. Let's look at some examples of the attribute-based access control policies here as it pertains to tagging. We looked at a tag called PII that was applied to one of the columns in the table. And we can write a policy here that says that wherever you see a tag called PII, HR and the data protection officer group, they have full permission to look at this data in HDFS. They can do read, write, or execute on any HDFS file or folder which has this PII tag. And in HBase, they're allowed to do read, write, etc. on columns or column families that have this at this particular property set. And similarly, the HR group can do all of these operations on the Hive tables or columns where this particular PII classification has been applied. So in this way, as and when you classify the objects within Atlas, those object and associations get transmitted directly to Ranger, and they can be used in policy enforcement as long as you have defined these policies ahead of time. So you can define these tag-based policies ahead of time, and as and when you ingest and classify your data, the protection will be dynamically applied as and when those objects are transformed within your ecosystem. Another important capability that we have within the ecosystem here, as it pertains to Apache Atlas, is that the classifications that we saw were being applied propagate. So, for example, if I tagged this employee table, then any derived view or derived table or any downstream processing will inherit or propagate that tag. So, if I applied a tag called um, PII here, that tag will be automatically propagated because of the lineage relationship that we have here to the UK employees table, and any tag-based policy that we defined in Ranger on the tag called PII will automatically be applied to UK employees as a result. And the way you will see these classifications here is that you will notice that the UK employees table, this derived table that we're looking at, has a classification called banking that was derived from this other table in the ecosystem, which is the employees table. Okay, so in this way, we can provide this full chain of custody information, give you the right level of access control and auditing to complement that, and also give you the ability to do this at scale using some of the different capabilities that we saw here in terms of compliance, which is around dynamic policies, dynamic anonymization, the chain of custody and lineage, and classification propagation, as well as metadata auditing. So we do have audits of each of the state of the metadata objects. We can see every operation from a metadata perspective that happened on this particular table. So for example, this was created by the Hive service user and then was updated by this particular ETL user, and the entity was further classified by this other user at this point of time. So we have a complete record of all of the changes that happened from a metadata perspective on this particular table in Atlas, and all of that can be leveraged in terms of classifications and other properties to be able to affect always on security and compliance within Ranger and in terms of the policy engine. We also have some other very fine-grained policy infrastructure available via a concept called security zones, where you can provide tenant-level isolation in a multi-tenant environment. So in this case, we have created a security zone called HR, where we can allot different resources. In this case, the path for the Hive database, which has this HR database from the Hive side, has been labeled as part of this HR zone, and you can set different administrators, and you can have your own policies for each of the piece of data or resources belonging to a particular security zone. So what this security zone definition here is showing is that the path within HDFS and the corresponding Hive database both belong to this HR zone, and it's administered through a range of policies by these sets of folks. And these sets of folks are the auditors who can look at the audit data and look at the policies without having to make any changes, without being able to make any changes to the policies or the access behavior. So the security zone infrastructure within Ranger, which is a new feature, which is only available in CDP Data Center Edition and not in the prior CDH or HTTP versions, gives you the ability to provide the multi-tenant isolation and coupled with resource isolation as well as policy and administrative boundary isolation around those resources. Another very important feature that we added, which is worthwhile pointing out here, is around RBAC or role-based access control. Ranger also supports, in addition to the attribute-based access control that we saw with properties such as the classifications or the resource properties themselves, we do have the ability to define new roles. In this case, there's an admin role that's defined to include the ETL group, and you can either add users or groups, and you can also set them as role administrators. And roles can also subsume other roles. And wherever you're able to use a user or a group, you can also use roles in addition. And we saw an example of that on this policy here, where we have not only the employee groups, but also the admin role that has specific access under these conditions. So what we've seen so far is CDP Data Center Edition provides very fine-grained security at the in terms of access control for different types of data um, across different services from a central console, and provides you dynamic row and column level security, dynamic policies, gives you complete chain of custody, metadata harvesting, as well as being able to use some of the metadata classifications effectively to drive security and other lifecycle decisions within this entire infrastructure. That's pretty much a quick tour through these capabilities, and I'll hand this back to others for summarization. Thank you.